Hi, my name is Brajesh Chaudhary and you're watching the Quantum Guru. In this video, I will investigate whether the coefficient of friction between the two surfaces can be greater than unity or not. When I ask this question to most of the students, they answer that it can't be greater than unity. So whether it can be greater than unity or not, we will see it through some experiment. And how to do that, we need to know how to find the friction coefficient between the two surfaces. So there are a few ways by which we can measure the coefficient of friction between the two surfaces, and one very easy method to measure a coefficient of friction between the two surfaces is the measuring the angle of repose of an inclined plane. So what is an angle of repose? Let's try to understand first. So suppose this is an inclined plane. This is an inclined plane of variable inclination. There is a protector being made here and there is some angle made here, and let me put this protector back to here, and here the protector is quite bright, and I can vary the angle of inclination of this inclined plane, and if I want, I can fix the inclination at certain position. So what happens? What is the angle of repose? Let's first try to understand. Suppose if I put some object over here and I want to gradually increase the angle of inclination. So there will come a moment at which this body will start slipping. So this angle that we can see here is the angle of repose. So angle of repose can be defined as when we start increasing the angle of the inclination, the first angle at which the body starts slipping is called the angle of repose. Or in other words, we can also say it is also equal to the maximum angle of the inclination up to the body cannot slip. If I increase a little bit more from that angle, the body will start slipping. So it's mentioned here. So suppose, say this is the angle of, suppose this is the angle, 1 minute, let me find the angle of repose of this body, like here. So suppose this is the angle of repose. So this angle is, so let's say this angle is, say this angle is, this is this angle. This angle is a phi. So if this inclination is phi, so if the inclination of this body, this inclined plane is less than that angle, so the body will not slip. Like if I put it somewhere lower, so this body will not slip. And if the angle of inclination is more than this angle of repose, the body will slip. So we can also say, suppose the angle of inclination of the inclined plane is theta, and angle of repose is phi. So if theta is less than equal to phi, the body will be at rest, and if theta is greater than phi, the body will slip. Now, so that we have understood what is the angle of repose, now let's see how we can use angle of repose to find the coefficient of friction between a body placed on the surface. Okay, so let's recall the concept of the static friction. We know that the static friction is the force that is a kind of a gluing agent. It tries to keep the two surfaces together, and to keep the two surfaces together, what it does, it can change its magnitude, can also change its direction. So it is in a way a self-limiting force, self-adjusting force. So it can adjust its magnitude from 0 to an upper limit. That upper limit is mu n, where mu is a coefficient of friction. That is a thing that we want to calculate, and we want to see whether it can be greater than unity or not. And n is the normal reaction between the two surfaces. So it can vary its magnitude, and when the body is about to slip, that is the moment when the body needs the static friction most. So it will give all its value. It will give all its value. It will offer all its value to prevent the slipping. So when the body is about to slip, the static friction reaches the maximum value. So suppose this is the angle of repose. So this is the angle of repose, means the body is just about to slip. So it means the friction would have reached to its maximum value. So I have drawn the FBD of this body. So maybe this might have been obstructing the view. So I have just put it here. So at this moment, this weight is mg is here. Component of mg is mg sin theta. This is mg cos theta. This is normal. Because this body is in equilibrium, so normal is balancing mg cos theta, and this friction Fs max has reached to the its limiting value, maximum value. So Fs max is mu n, that is equal to this is balancing this mg sin theta. So if we divide these two equations, I put it the value of n as mg cos phi. So if we divide these values or these equations, what I will get the mu is equal to tan phi. So knowing angle of repose, we can find the coefficient of friction between the two surfaces. So now that's pretty simple how to calculate the coefficient of friction between the two surfaces. Try to find, just place a body on an inclined plane and find the angle of repose, then the coefficient of friction is tan phi. And we know that tan 45 is 1. So if angle of repose is greater than 45, so it means the coefficient of friction is greater than 1. If the angle of repose is less than 45, it means the coefficient of friction is less than 1. So now I want to again, let me put this body over here. So I put this body here. So body is here, and I have this object. This is a simple eraser, and this surface is smooth, and this surface I want to make it rough. So already created some roughness, but still I want to create more roughness. So I am just creating some more roughness here. So that way the friction coefficient may increase a little bit. So I am creating some roughness here, and now let's start with the surface, the smooth surface. So I have put it here, and let's go, and this is at 0. Now I will gradually increase the angle of inclination. 1 minute, let me loosen this. Yes, so I am gradually increasing the angle of inclination. Let's see what happens. Not yet started moving, not yet, not yet, not yet. Yeah, so this is the angle of repose. So let me check it. What is the angle of repose here? So the angle of repose here is, yeah, this angle of repose is 39 degree. So this angle of repose is 39 degree, well below 45 degree, mean the coefficient of friction between this surface of this eraser and this surface is less than 1. Now I will do it again, but now with this surface. The surface I have created some roughness here. So whether by creating roughness the coefficient of friction has increased or not. So again I am starting from 0 degree inclination, and I will gradually increase the angle of inclination. Here we go, here we go, here we go. Not yet started, not yet started, not yet started, not yet started. Oh, not yet started, still it has gone past. It started well above this. The maximum angle here, this angle you can see 45, this might be 60. So that started moving at angle greater than at least 60 degree. So in this case I have created lot of roughness here. So let me just smoothen it a little bit, and so in this case at least the coefficient of friction between this surface and this is greater than 1. So let me do this again by choosing some other surface. I can take the same surface, but right now I can create a little bit smoothness. So let's see now what happens here. So I am doing the experiment again with the same surface, just I have created some I have just smoothened the roughness a little bit. here. So not started yet, not started yet, not started yet, not yet, not yet. Now it started. So this is the angle of repose. This is the angle of repose. It has started sliding slowly, almost with zero velocity, right? So this angle is the angle of repose. This angle is the angle of repose, and the maximum angle that it marking here is the 45 degree, and the angle up to here is 45 degrees. So this angle is 45. So this angle is around 60 degree. So I have shown you that the coefficient of friction between two surfaces can be greater than 1. The surface is quite rough. The coefficient of friction between the two surfaces can be greater than 1.